So, what is Vedic Maths? Vedic Maths is a collection of techniques, sutras, to solve many arithmetic problems and mathematical problems in an easy and faster way. It consists of 16 sutras and 13 sub-sutras which can be used for problems involved in arithmetic, algebra, geometry, calculus and conics. It was discovered by Indian mathematician Jagadguru Bharati Krishna Devi. Veda is a Sanskrit word, and in Sanskrit it means knowledge. Basically, Vedic Maths means to impart our knowledge of the Veda to solve arithmetic problems easily. Using regular mathematical steps, solving many problems sometimes are very complex and time consuming. But using Vedic mathematics, general techniques, which are applicable to all sets of given values, and specific techniques, which are applicable to specific sets, numerical calculations can be done very fast. Vedic mathematics can definitely solve mathematical numerical calculations faster, but these scholars believe Vedic maths tricks can help you to solve certain values 10 to 15 times faster than the usual methods that we generally use. So let's start by learning how we can learn ourselves learn these techniques. So the first tip that I have for you today is how to multiply a number by 11. Suppose we have to multiply 345 by 11, right? 345 by 11. Put the numbers 345 and 11 above and below each other like we usually do for our normal multiplications. Take the rightmost digit, in this case 5, and write it down as ones digit of your answer. So here we have obtained the rightmost digit of our answer. Now take the tens digit, here 4, add it to 5, make it 9. This will help you get the tens digit of your answer. Now take the hundreds digit, in this case 3, add it to its next digit, that is 4, will get 7. Write down that as the hundreds digit of your answer. And finally, we have to continue doing this until we reach the last digit, and when we reach the last digit, we just copy down that leftmost digit, in this case it is 3, and write it as such as the leftmost part of our answer. So friends, 345 by 11 is 3795. So wasn't that easy? Okay, let's get to a bit more complex problem in the same category. Suppose we have to multiply 635418 by 11. Put the numbers 635, 418 and 11 above and below one another. Take the ones digit and write it down as the ones digit of our answer. In this case, we have 8 as the rightmost digit. We'll take that as our answer's rightmost digit, that is the ones place. Now we continue doing the same thing as we did in the last question. So we add 1 to 8 and bring 9 as the tens place of our answer. Then we take 4, add it to its next digit, that is 1, we get 5, and we write that down as the hundreds digit of our answer. Then 5 plus 4, 9, 3 plus 5, 8, 6 plus 3, 9, and when we reach the last digit, we simply copy that digit as it is. So 6 will be the leftmost digit of our answer. So 635418 into 11 is equal to 6989598. So that is how easy it is to multiply by 11, and you can have any number as big as it is, the method would remain same. Now we sometimes face a challenge. The challenge is, as of now, the two techniques that we have done, we have not got any number which or any sum of two numbers which had a carryover. So what to do when we have a carryover? Let's see that. So suppose 65448 is to be multiplied by 11. We put the numbers 65448 and 11 above and below each other. We take the rightmost digit, in this case 8, and write that down as the ones digit of our answer. So we get 8. Then the next digit, that is 4, we'll add it to 8, we will get 12. So now, since 12 is a two-digit number, what we will do is that we will write 2 as the main tens digit and write 1 as the subscript to be carried forward as we do in normal addition. So then we take hundreds place digit, that is 4, and add it to the tens digit, that is 4, we get 8. Then again 5 plus 4, 9, 6 plus 5, 11. Again it is a two digit number. So ones place of this number, we'll take that as the real digit, and we will keep the tens place of this sum to be carried over. Finally, after reaching 6, that is the leftmost digit of the question, we will simply copy down it as it is. So we get this thing. Now what we have to do is, we have to simply add the carried forward digits to the next digits, that is the subsequent places. So 8 will be coming down as it is, 2 will come down as it is, 1 we will add it to 8 and get 9 as the answer, 9 we will brought down as it is, 1 again will come down as it is, and the 1 that was to be carried over will be added to 6, and we will get 719928 as our final answer. So in this way, any number that you have to be multiplied by 11, you can simply do that by using the same method. Method will not change whether it is a 2-digit number, whether it is a 3-digit number, whether it is a 10-digit number, any digit number there you have, we will simply have the same method to be followed. So I hope multiplication by 11 is clear to everyone. So the second tip or trick that I have for you today is how to multiply two numbers. These numbers can be two one-digit numbers, these can be two two-digit numbers, these can be two three-digit numbers, four-digit numbers, five-digit numbers. The method would remain same. Why we are starting with two one-digit numbers? The simple reason being, since it is easier to understand the method for single digits, so we start by single digit numbers, but subsequently we will take it above to 2 digits, 3 digits, 4 digits, and you can apply it to any number of digits. So before starting with the number or the method, I will like to tell you one thing. Whenever we are doing a multiplication, number one, this method is applicable to all type of numbers. Numbers can be 2-digit numbers, number can be 3-digit numbers, and you can also have a 1-digit number being multiplied by 2-digit number, or a 2-digit number being multiplied by 3-digit number, and so on. But for ease of understanding, in this presentation I am sticking to numbers which have the same number of digits. So let's start with two one-digit numbers. So let us suppose we have to multiply 9 by 7. Yeah, I know, it is very easy. 9 sevens are 63. Everybody would laugh away, right? But until we understand this method for 9 multiplied by 7, we will not be able to understand it for say 98 into 97, or for that matter 998 into 997, or for that matter any number of digits. So for this calculation, we will take as base for our calculation that power of 10 which is nearest to the number to be multiplied. In this case, 10 itself is that power. So nearest number to 9, 7 that has a 0 at the end is 10. So we take 10 as the base for this question. So now put the numbers 9 and 7 above and below on the left hand side. So this is 9 and 7. Subtract each of them from the base. So now what is 10 minus 9? It is minus 1. And what is 10 minus 7? It is 3. So we will write these 1 and 3 alongside 9 and 7 with a minus sign in between. Minus sign shows that the number 9 is less than 10 by 1. If we had 11 by 7, we would have written plus 1. But then again, I am not taking you to that layer right now because that would become confusing. So after that, after writing in this way, our answer has two parts. One is the left side of the answer and one is the right side of the answer. So for ease of answer, we will put a vertical line that may be drawn for demarcation of these two parts. Now, the real work starts. So we have to cross subtract. Cross subtract means either you can subtract 3 from 9 or you can subtract 1 from 7. In either case, we get 6 and we take that as the left hand part of our answer. So 9 minus 3 is 6 or 7 minus 1 is 6. We take that as the left hand part of our answer. Now what to do for the right hand part of the answer? It is again very simple. 1 into 3 is 3. So we'll simply write 3 as the right hand part of our answer to get 63 as the final answer. I'll quickly go over again this method. First of all, we will write the two numbers that we have to multiply. Then we will choose the base, that is the number ending in 0, which is nearest to these two numbers. Then we will write the deficiency or excess over the base. Means if 9 is less than 10, we write minus 1. 7 is less than 10 by 3, we write minus 3. Then we cross subtract. 9 minus 3 is 6 or 7 minus 1 is 6 and write that as left part of our answer. And we multiply the two right parts, that is minus 1 and minus 3, or simply you can say 1 and 3 since we are not getting into the signs as of now. So 1 into 3 is 3. We'll take that as the right part of our answer to get 63 as the answer. Why this was important to learn how 9 and 7 multiply to solve things like these. When we have 2-digit number as an answer on the right, what we can do. Second scenario. Suppose you have to multiply 4 and 7. Again, as base for our calculation, because 4 and 7 both are near to 10, so we take 10 as our base. We write 4 and 7 above and below each other on the left hand side. We subtract them from 10 and write the deficiency that there is, that is 10 minus 4 is 6 and 10 minus 7 is 3. So we write 6 and 3 with a negative sign with both the numbers, right? Then again we will draw a line demarcating the two parts of our answers, the left hand part and the right hand part. We will cross subtract. 4 minus 3 is 1, 7 minus 6 is 1 and take that 1 as the left part of our answer. Then we multiply 6 and 3. When we multiply 6 and 3, we get 18 as our answer. But the thing is that the base that we have chosen for this particular calculation is 10. Since 10 has got 1 0, so we can only have one digit number as the right hand side. So if we are getting a 2-digit number, in this case we have got 18, we will keep its ones place as the right part of the answer and shift 1 to the other side, right? So 1 that we have, we will take it to the left part, which makes 1 plus 1 equal to 2 and we get 28 as our answer. So now since we have learned the scenarios, in case of simple calculations, let us try to do a bit harder calculations. Till this point you would not have understood in these multiplications that how is it helping you, right? Yeah, I understand. You would think that how these are going to help us. 9 sevens are 63, 4 sevens are 28, we can easily do. But wait, look at these numbers now. Can you do 98 by 96 verbally? No, you can't. I hope you can't. I have been teaching for 20 years, maybe I can't even. So 98 by 96. Again, method remains same. The beauty of Vedic Maths is number of digits do not make any change to the method, right? So in this case, since we have got 2-digit numbers, so we will choose 100 as our base because we need 2 zeros, right? Again we will write 98 and 96 above and below each other. Since we have chosen 100 as the base, we will subtract them from 100 to get -2 and -4 as the deficiencies. Then 98 minus 4 or 96 minus 4, the same way as we did for the previous sums. We'll do that. So 98 minus 4 is 94. 96 minus 2 is 94. So we'll take 94 as the left part of our answer, right? Vertically multiply, again 2 4s are 8. So we'll take 8 as the right part of our answer. But one important thing, since we have chosen 100 as the base, so we now need a 2-digit number as the right part of our answer. So we will not simply write 8 to make the answer 948. We'll make it 9408 because the base has 2 zeros, so we need a 2-digit number. This condition of base having number of zeros equivalent to the answer does not apply for the left hand part. It only applies on the right hand part. So we will not write 8, we will write 08 to get 9408 as the product. You can very well appreciate that in these questions we do not have actually multiplied anything by using a pen or a paper. In fact, we have not even subtracted or added anything using a pen and paper. But otherwise, if you have to multiply 98 by 96, I presume it is difficult to do without a calculator or without using pen and paper. But here we have not used any, right?
Subscribe to our channel and hit the bell icon to continue receiving all notifications as we post new videos.
So let's do a bit more tricky sum. 998 by 997. So what will be the base for these numbers? Yes, since it is a 3-digit number, right? Since it is a 3-digit number, we will have to choose 1000 as the base. We will take 1000 as the base because it is a 3-digit number. Yeah, you can go on writing something in the chats. I'll go through the chats later on, right? So, moving ahead, 998 and 997 will write above and below on the left hand side. Again, subtracting them from the base. Now, what is 1000 minus 998? Does anyone need a calculator for that? No, it is 2. And what is 1000 minus 997? It is 3. Again, no calculator required. So, we write that with a minus sign to show that it is a deficiency, that it is smaller than 1000. If the numbers were greater than 1000, we would write plus. Again, the product has two parts, one left part and one right part. To know the two things, we'll mark a line to demarcate left and right parts. Cross subtracting the deficiencies, so 998 minus 3 or 997 minus 2. Whatever we do, in either case, the answer would be 995, right? So that we get as the left part of our answer. Further, 2 into 3 is 6. So 6 is the right hand part of the answer. But do not forget what we have to do. Yes, the base is 1000. So we need a 3-digit number in the right part of the answer. So instead of writing 6, we will write 006. Instead of writing 6, we will write 006 to get 995,006 as our final answer. Right? Let me do two more sums for you as examples for each of these two methods. Okay, the first one that I am taking is multiplication by 11. So 5346 257 into 11, right? So first number 7, bring that down as it is, add 5 and 7, we get 12, add 2 and 5, we'll get 7, 6 and 2, we get 8, 4 and 6, we get 10, 3 and 4, we get 7, and 5 and 3, we get 8, and we bring this 5 down as it is, as the leftmost part of our answer. So going ahead, 7 as it is, 2 as it is, add this 1 to 7 to get 8, 8 as it is, 0 as it is, add this 1 to 7 to get 8, 8 as it is, 5 as it is. So no multiplication, no nothing, simple additions, right? And now comes the magic. Let us suppose we have to multiply 999989 by 999993, right? It is a 1 2 3 4 5 6 digit number. So base that we will choose is a 6-digit number. Subtracting 999989 from 10 lakh, we get 000011, and subtracting 999993 from 10,000, we will get 000007, right? Simply you can do all from 9 and last from 10. This also can be used. So cross subtract that I have been telling you. You can subtract 000007 from 999989, or you can subtract this from this number. Any which way you do, you will get this. And multiplying 11 and 7, keeping in mind the number of digits, 11 sevens are 77, and since we have to complete 6 digits, we add 4 zeros. So friends, this is the answer of the multiplication: 999982000077. And believe me, even calculators fail to give this answer sometimes. And since I have been instructing you, it took me more time to solve this sum. Otherwise, when we know the trick and are doing it on our own, it will not take even this much time. Yeah, it will not take even this much time. I have seen kids in 3rd standard or 4th standard doing such big calculation in less than 15 seconds using these tricks. So it is helpful for all normal mathematical calculations that we see happening around us, or that kids have to do in their exams, in their normal mathematics, right? So coming back after these two examples, so I'll be having a few practice questions for you. You can note them down and you can try them on their own.
For more informative videos, subscribe to our channel and also hit the bell icon so that you are notified whenever we release a new video. Thank you from Horizons.